probably the most important piece of this slide so far for today's purposes. If you have, this is called the factor theorem, if you have information about either a factor of a polynomial or an x-intercept or a zero, if it's a real zero, an x-intercept, a real zero or an imaginary zero of a polynomial, then you automatically have information about the other. So a zero tells you something about a factor, and a factor tells you something about a zero. They go both ways. So what am I saying? Well, for example, looking at the one we just did, it's an expanded form. Right now, I have no idea what factors or what x-intercepts I have of this polynomial. But if I were to give you some suggestions, like, maybe 1 is a maybe 1 is an x-intercept, maybe -2 is an x-intercept. By giving you those pieces of information, you could then plug them in directly and see if you get 0 when you plug them in for x. That's one way to check. Or what you could do is use long division or synthetic division, which we're going to hopefully get to today, to check whether or not when you divide by that factor, you get no remainder. Okay? Because if you think about what it means to be a factor, think about a number like 15. All right? If I said, what are some factors of 15? You'd say 3 and 5, 1 and 15. Right? But if I said, hey, what about 2? Someone walks in and says, is 2 a factor of 15? I feel it. What would you do? You divide it. Does 2 go into 15 without a remainder? And you find a remainder and you say, nope, that's not a factor. Because to be a factor means when I divide by this number, I get no remainder. Right? So later today, we'll do long division to check if a factor really is a factor. Is there a remainder? All right, so what am I saying here? If I told you, for example, that 3 was a x-intercept of this polynomial, I'm making that up. It turns out if 3 was an x-intercept of this, then x minus 3 would have to be a factor. Well, that's interesting. Let me show you one that you might actually believe. What if I had some